So how does a nation go from a single, kind of humble nuclear reactor to literally peering back into the first moments of the universe? Well, it's an absolutely incredible story of scientific ambition, and we're about to dive into how it all went down.
You know, every great scientific leap really starts with a visionary. And for India, that person was Dr. Homi J. Bhabha. He had this amazing foresight. He didn't just see the potential of atomic energy. He knew that to truly master it, India had to build its own tools, right from the ground up.
And that's really what this is all about. This is a story about that incredible engineering journey. It's about how a deep-seated curiosity about the universe's most fundamental building blocks led to creating some of the most complex, mind-boggling machines on the planet.
All right, so where do you even start on a journey like this? Well, the very first step was figuring out how to harness the immense power locked inside the atom's core. And for that, you need a very, very specific kind of tool, a research reactor.
So let's meet the first workhorses of this new age. Over on the left, you've got Apsara, India's very first nuclear reactor. Now, it was a pretty modest 1-megawatt machine, but it was a huge deal at the time, a monumental achievement. Then, a little later, came Cirrus, a much more powerful 40-megawatt reactor. And that really kicked the door wide open for way more complex and ambitious experiments.
So, with these brand new tools in hand, the real work could finally begin. This picture here, it shows an early experiment at the Apsara reactor. I know, it kind of looks like a tangle of wires and machinery, but this is it. This is where the fundamental secrets of the atom were first being unraveled right on Indian soil.
So what exactly were they looking at? At its core, it was all about this one process, nuclear fission. This is that incredible moment where an atom's nucleus splits apart, unleashing just a massive amount of energy. Understanding this, and more importantly, controlling it, that was the key to absolutely everything that came next.
And you know what? The breakthroughs started coming in and fast. They managed to precisely measure the neutrons that were shot out during fission. They studied the spin of the fragments that were left over. And then they found something really surprising. About 10% of the neutrons were actually being emitted before the nucleus had fully split apart. Now, why does that matter? Well, think of it like this. It was a crucial clue, a little peek behind the curtain of an unbelievably fast and violent event. It gave them a much deeper understanding of that chaotic split-second process, which is totally essential for controlling reactors and, just understanding basic physics.
But just watching fission wasn't enough. To really get to the bottom of how the atom works, they needed to go deeper. They needed to smash particles together with incredible force. So it was time for a whole new generation of machines, particle accelerators.
And this quote right here, it just says it all. Particle accelerators are literally the engines of nuclear physics. These are the machines that let us, for a fleeting moment, recreate the conditions inside a star or maybe even the conditions right after the Big Bang itself.
Just look at this timeline. It shows the incredible pace of progress. It started out pretty small back in 1953, but the ambition grew super fast. By 1962, a more powerful Van de Graaff accelerator was up and running. Then came the variable energy cyclotron in the 70s, and this all led up to the mighty 14-megavolt Pelletron accelerator in 1988. Every single one of these was a huge leap forward, a quantum jump in the kinds of questions they could start asking the universe.
Oh, this slide is just perfect. It really captures that sense of history and progress. On the left, you see the inauguration of that first Van de Graaff accelerator in '62. And on the right, that's the modern FOTAI accelerator, installed decades later in the exact same building. It's just such a powerful visual of how far the technology has come.
And that brings us to the Pelletron, a true behemoth. I mean, look at this thing. This massive machine was a total game changer. It became a major research hub, opening up entirely new fields of study by accelerating heavy ions to almost the speed of light.
Okay, so with these incredibly powerful machines now online, the research could shift gears. It could move from the nucleus of the atom to its most fundamental elementary bits and pieces, the very fabric of reality itself.
And this allowed scientists to start asking one of the most profound questions you can possibly imagine. What was the universe actually like in the first few microseconds of its existence? To answer that, you have to recreate those conditions.
The answer, it turns out, lies in creating something called quark-gluon plasma. It's this exotic state of matter that's so incredibly hot and dense that protons and neutrons literally dissolve into a kind of primordial soup of quarks and gluons. For just a fraction of a second after the Big Bang, this is what the entire universe was made of. Wild, right?
And this is where India's nuclear program really stepped onto the world stage. BARC scientists started collaborating on experiments in the US, and, probably most famously, at CERN's Large Hadron Collider in Switzerland. They actually helped build critical components for the giant detectors there, playing a direct role in huge discoveries, including the hunt for the Higgs boson.
So, to catch a glimpse of these particles that only exist for a fraction of a second, you need something like a super-powered, super-fast camera. And this is what the inside of one of those experiments looks like. It's just this incredibly complex web of detectors, all designed with unbelievable precision to capture the absolute faintest signals from particles smashing into each other at nearly the speed of light.
But the work doesn't stop there. Beyond just smashing particles together, BARC is also involved in chasing some of the most mysterious and, frankly, weirdest particles in the entire universe.
Take a look at the ISMRN detector. Its mission? To hunt for neutrinos, these tiny, ghost-like particles that can pass straight through solid matter like it's not even there. This is India's first major step into the world of neutrino physics, which is yet another new frontier in our quest to figure out how the universe works.
So when you step back and look at the whole arc, you can see these really clear, ambitious stages of the journey. It all started with one person's vision. That led to the foundational work with the early reactors. Then came that giant leap forward with powerful accelerators, which brought Indian science right to the cutting edge of global physics.
And over more than 75 years, that dedicated journey has transformed what started as a humble beginning into a truly world-class scientific powerhouse.
And that journey is still going, from a single generator in the 1950s to helping probe the very dawn of time itself. The ambition has only grown bigger, and that leaves us with one final, pretty exciting question. What secrets about our universe will the next generation of these incredible machines unlock?